Well, thanks for the invitation today. I really appreciate the time on your agenda to talk about the CNSF system resiliency. Next slide. So I don't think that I have to tell the folks that are on this call or in the room there that, you know, the community resilience is something that's very collaborative and that there are layers and levels. And so here to talk about the Army Corps of Engineers efforts and our recognition that our efforts have to be tied in and collaborative with with efforts that are happening at all levels. The problems, you know, related to climate change, the uncertainty, the complexity. It's essential to survey and assess the relationships among all of the private and public sector deliverables and the capabilities. We just saw the presentation that Mike gave us, and that Akun is a valuable tool. And the idea of adding freshwater into that model as the Akun Plus is something that we're aware of and interested in. So all of these efforts bring something to the table. And obviously the goal is to look at resilience and quality of life. And so as the Army Corps of Engineers, we engage in infrastructure, clearly, but our projects intersect all of the things in that wheel very intrinsically. And the CNSF system connects all of us really in Central and Southern Florida. And so, next slide. So the system was originally designed with these 5 project purposes. But as you can see, the system intersects the coastline at all these points, right? So as sea level changes, the performance of this system is subject to change. And the other factor that's been discussed today and is of importance to this system are changes to rainfall climate. And so it's just notable that this system designed to provide these project purposes is obviously impacted by climate change. And so the effort on resilience on our part, and in partnership with the South Florida Water Management District and all of the stakeholders and agencies in this part of Florida and the tribes, is to evaluate this system and reevaluate this system and make sure that we are operating it or even modifying it in a way to maintain its resilience to those changes. Next slide. So how does it fit together, right? So collaboration is the key. That's why I'm here today, and that's why we're all here. So we're trying to assess those impacts and connections and dependencies. And as we set up our studies with the Army Corps, many of you have been involved in those. There's a very elaborate public engagement, and we involve our project delivery teams, involve agencies and experts from all across the spectrum. Because we have to understand these relationships, economies of scale. We have to make sure that we're looking at how to adaptively plan and implement this infrastructure in the context of the actions taking place within the system or connected with the system. And obviously now that the future is known to be different than the past, which is not the way that a lot of these systems were designed, that adds a dynamic element to this. So if it wasn't complicated enough, right, it's now got the element of change through time. Next slide. And so in my group within the Army Corps of Engineers, not only do we look at the hydrology and the hydraulics, the coastal storm risk, but we're also operating this system in concert with the South Florida Water Management District. And so how do our water managers think about this system? The CNSF system connects all of us, right? And it starts in the Kissimmee River chain of lakes, makes its way down to Lake Okeechobee. Ultimately, south of there, it makes its way to the conservation areas in the Everglades Protection Area and the Everglades National Park, Florida Bay. But obviously, the lake is also connected with the east and west. And there are distinct opportunities, but also impacts to be assessed. And so as we think about the system and how it's been operated in the past and in the present, we're also thinking about how do those connections change as climate changes. Next slide. And so a lot of the folks on this call and in the room there will be familiar with our Lake System Operating Manual process, right? So we operate Lake Okeechobee. We regulate the water flowing out of the lake east, west, and south. And of course, operating the systems that are connected with the lake as well. And so that process involved, to date, 2 years, and ultimately it will be 3 years of really intensive stakeholder engagement. We have, as I said, a PDT that includes scientists and engineers from many agencies, state and local and federal agencies, as well as the Army Corps of Engineers. It includes the Seminole tribe, the Miccosukee tribe, and experts from all of these areas shown on the screen, and public engagement by all of these groups. And so because this system touches hundreds of thousands, millions of people, LOSOM has been an example of how we will engage. And so as we look at system resilience, it's going to look a lot the same way, right? Because if you touch one part of this system, changes propagate throughout it, potentially. Next slide. So there's a series of slides here that show Palm Beach, Broward, and Dade County as an example, but this applies on the West Coast or north of Lake Okeechobee the same way. So understanding the CNSF system is key. And when you look at this image, depending on your role or your expertise or where you live, you may look at it differently. We have the CNSF system in Herbert Hoover Dike that encircles the lake. We have coastal storm risk management projects that the Army Corps of Engineers works with municipalities and counties to build and maintain. We have navigation projects that are essential to the economy and infrastructure of those areas. In this figure, the dots are generally water control structures, locations where those canals are regulated. The canals are shown in the light blue color there. And what this means is that all of these projects are connected. And one of the things that's been a characteristic of the programs is that the CNSF system obviously was designed at a time when climate change was much less well understood. And so there was a tendency to look at that system and understanding that it intersected with the coast, but assuming that the future would be the same as the past. Nowadays, as I've said, we know that to be false. We know that the conditions along the coastline and sea level are changing. We know that rainfall patterns are changing, storms are changing. And this means that these projects are not just next to each other, they're interconnected. Right. So as we look at coastal storm risk, we have to look at the performance of the CNSF system. And we have to look at the combination of rainfall-driven flooding with coastal flooding, for instance. And so I'll use the example again of the Accoon Plus. That is an example of how to bring in freshwater and coastal storms and sea level change and put them together. And so that is similar to efforts that we will do, and we would like to leverage information like that as we look at resilience in these systems. Next slide. So this is similar information for Dade County. This is the southern part of Dade County is particularly vulnerable to sea level change. The areas down there by the squares 3 and 4 are extremely low lying. Those canals and the structures that are close to or right adjacent to the coastline are already being affected by sea level change. And so when you have a structure that flows water by gravity and the ocean rises on the downstream side of it, it affects the ability of that structure to flow water. And so we're already seeing an impediment to flow in these structures from sea level change because they already did not have much head, so to speak, to flow water. And so those are some of the highest urgency areas. And the South Florida Water Management District has been evaluating the vulnerability of those through their flood protection level of service. That's something that if you look it up online, you can learn more about their effort. And it prioritizes all of these structures in terms of vulnerability to sea level change and how that affects their function. And so that kind of work by the state is essential as we work with them And we all work together really to evaluate this system and make sure that it's ready for the next 100 years. Next slide. So I mentioned earlier where the watershed-based approach, inland flood risk management, inland multi-purpose projects like the CNSF system, and coastal projects might have at one time been considered somewhat separate, but they're no longer separate. Our navigation projects and our coastal storm risk projects, we're looking at studying what are estuarine and bay shorelines through beach and back bay studies. Those are connected with the CNSF system and affected by it. We have a program called the Regional Sediment Management. So sediment becomes scarce and valuable in these systems, particularly sediment for beaches. But as we dredge sediment, it becomes a resource rather than a spoil or something to be disposed of. The South Atlantic Coastal Study, if that's not something you've heard of, it might be an interesting thing for you to look up. You can just use a search engine and look for those terms. That is a study that we've been conducting for several years across the entire southeastern United States to quantify the vulnerability to coastal storms. That's going to be foundational information for us as we evaluate the central and southern Florida system for resiliency, because it updates the science of storm climate and storm impacts on our coast, which obviously affects the CNSF system. And on the left-hand side, while we're conducting water management and operations, we're constantly operating the system 24/7, 365. We're also changing the CNSF system through the Comprehensive Everglades Restoration Plan, CERP, right? So we're modifying the system to undo some of the harm that it did when it endeavored to deliver those 5 project purposes. And then ultimately, the CNSF Flood Risk Management Infrastructure Resiliency Study. This is a study that Congress recently approved for the Corps and the Water Management District to embark on. And so there's what's called a feasibility cost sharing agreement. That's a legal agreement that puts us in a partnership for that study. And that's going to be executed this spring and early summer, and then we'll begin scoping that study. And so everyone here will probably get emails being invited to scoping discussions on that. We welcome everyone's participation in that. And we're excited to start that process. The work by Dr. Gerardo and Dr. Severies, all of the experts that have been presented here come into those studies. That is an open and inclusive effort. Next slide. So this is my last slide, and it's just a picture that we use sometimes to communicate. We have a lot of experts on the line, but we use this a lot of times to discuss the different types of measures that can be combined into plans to address flood risk, resilience, water supply, recreation. Some of these features supply more than one of those. So some of the notable things, you see breakwaters and groins, beach and dune restoration, but you also have natural and nature-based and living shoreline type solutions. You have levees and flood walls, which we have prevalent in our central and southern Florida project, canals, pumps. But these things work together, right? And they're not all implemented by the federal government by any means. Some of these have already been constructed and need to be adapted. Some of these are just a dream. And so as we put together combinations of these measures, and that's why this has to be inclusive, because some of these will have been implemented by the locals or the state, and we just want to make sure that our plans bring it all together. And so I'll just end with a note that we like to remind people that as we've restored the Everglades itself, the Everglades itself is a natural and nature-based feature and with a huge benefit. And so as we look at projects like the Biscayne Bay Southeastern Everglades Restoration Study and the projects that we're building all around the state for CERP, those enhance the resilience of our system. So while they were designed for ecosystem restoration, they're also resilience projects in their own right. And with that, I'll end. I know I'm out of time. Thank you. Okay, so I'm just going to start from the upper left. Why are we spending so much energy on resilience when we should be stopping and reversing the warming? I guess the way that I view this is that we should be doing both, right? So there's a need to adjust to the changing conditions while we also seek to alter the future in a way that minimizes the future changes. But since the changes, like I said, in Miami-Dade County are occurring right now, we have to address resilience of the system and function of our system where we live, that we live in and among, because those changes are already here. What maximum sea level rise is the Army Corps planning for? This is a really good question. So the Army Corps we have our sea level change guidance. It's in pretty close alignment with the NOAA guidance, but we also, as we evaluate our projects, we consider other climate change or sea level change scenarios. And so if we address projects in Southeast Florida, where they have developed their own sea level change scenarios, we can look at those as part of the design of the projects, and we have. What type of projects are going on in Lee, Collier counties and Caloosahatchee? So a few of them off the top of my head would be looking at LACO system operating manual and altering the releases from the lake and trying to make those environmentally friendly as possible. The C-43 reservoir is being built up near Lake Okeechobee to take lake water when there's too much of it, and to meter that water out down the river when there's not enough water in the lake and the river needs the water. So there are projects in SERP that are meant to provide a more natural flow of water down the Caloosahatchee. There are coastal projects in the counties in southwestern Florida, multiple coastal storm risk management projects, beach projects. There's a Back Bay study in Collier County that the Army Corps is conducting. So there are quite a few. And as we look at system resilience of the central and southern Florida system, the Southwest Florida will be along for that as well. Can you clarify the relationship between South Florida Water Management sea level rise and flood resiliency plan? So as we engage with the district, they are working on plans and science behind those plans. So one example I would give is that the district is working with the state on developing climate change scenarios for rainfall and hydrology. So this is really essential for Florida, and especially for the central and southern Florida system, is to understand when we want to simulate the future, we need to have scenarios like we have for sea level change. We need to have those for rainfall, and to determine how the system might need to be able to be resilient to higher peak flows, greater droughts, changes in average patterns of rainfall, and the extremes. I recognize the structures are already in place and rely on them, and people rely on them. Are there plans going forward to remove structures and return conditions to more natural ones? So yes, right, the SERP program is removing structures, plugging canals, installing pumps to redistribute water. We are building storage in the system that was lost when the system was modified. So the C-43 was a reservoir, the C-44 reservoir. There's a lot of work going on to modify the CNSF system as part of SERP to remedy some of the problems with the distribution of water and the timing. And that's the purpose of SERP. So yes, there are changes happening in the system in north, south, east, and west as part of the program. And as we address the resiliency, I fully expect that we will evaluate operational changes and structural changes as options to enhance the resilience of the system. So SERP is already making some of those changes. The resiliency work that we will do will very likely bring on additional rounds of change.